Moving into the future, we're looking at energy policy. We've talked to you in the past about distributed energy systems. We talked to you about how to improve the whole building envelope. We talked to you about improvements to the grid that are needed. But one of the issues that was probably most important is the development of storage technology. That is really the answer to many of the questions about how we will use energy in the future. To understand this better, it helps to understand some of the basic facts about electricity. So breaking down how electricity works requires looking at some of the smallest particles of an atom, known as electrons. When electrons are forced to move in sync, they end up causing friction, which leads to heat, and then the creation of an electric charge. Electricity is the result of the accumulation or movement of these electrons. So when electrons accumulate and collide naturally in the atmosphere, electricity is created, which dissipates in several forms, such as static electricity, lightning, and even the natural phenomenon such as northern lights. But when a closed circuit is created, forcing electrons or electricity through electric wiring, you can transport electricity to power homes, buildings, factories, and appliances and electronics. Now there's a lot more scientific detail involved here, the structure of atoms, electron flows, direct and alternating current, but the key takeaway here is that electrons and electricity must flow in a current, be stored in some way, or it dissipates into the atmosphere. The basic science is reflected in design of our national electric grid. We generate electricity in one place, but we can't store it, so we send it down the grid. Maine generates electricity and sends the extra electricity to Massachusetts. Massachusetts sends it to Connecticut, Connecticut to New York, and so on. In terms of advancing decarbonized electricity, this means that if we generate renewable energy, we need to be able to store it effectively. The problem is that we lack the adequate storage technology to support the amount of energy needed. However, this doesn't mean that we don't have the foundations of this technology. There are several key types of storage that are available. Thermal storage, for example, also known as TES, is a technology that stores energy by heating or cooling a medium for later use. Thermal storage is a very fascinating technology. One of the things that many people don't know is that under Reagan National Airport here in Washington, D.C. is a thermal storage facility. In fact, there is a piece of ice that actually is the exact same size as the runway that is frozen every night using energy that is created during off-peak, and then during the day, air is blown over that piece of ice to cool many facilities within the airport as well as buildings within the surrounding area. Another type of significant technology is hydro storage or pumped storage hydropower. This technology stores and generates electricity by moving water between two reservoirs at different elevations. It is the most common type of energy storage on the electric grid in the United States. While thermal storage and hydro storage are interesting new types of technology, the technology that we're most familiar with is battery storage. One of the battery technologies that you're most likely familiar with are lithium-ion batteries. But these batteries pose a significant challenge in everyday use and particularly within the building envelope. The number one problem with these batteries is that they will actually ignite and catch on fire when they're not properly charged or stored. This is additionally compounded by the fact that these batteries, when they are on fire, create their own oxygen, and they're almost impossible to put out once they've been ignited. Other problems with these batteries are the actual chemical elements within them, particularly the cobalt that's required to make the battery more efficient. Cobalt is a very rare earth mineral, which is difficult to mine, has significant environmental drawbacks. Now, there's several new types of batteries that are in development. Zinc bromide flow batteries, they offer a safe and sustainable solution for energy storage. Organic flow batteries with solid materials increase storage capacity compared to conventional low batteries. Importantly, and maybe the most efficient, are the sulfur-sodium batteries. They function at a high temperature, but have proven to be very safe in tests. In the coming year, we're going to see Congress do a great deal of work in terms of how they're approaching the Department of Energy and the types of research and development that are being done. It is essential that we begin to look at these alternative types of storage that are safer, more economical, and if the research and development is done properly, we can actually see more efficient, long-lasting batteries. Why were we talking to you about all of these issues relating to batteries and storage? Well, it's because of the movement towards electrification. The need for storage is rooted in the move towards renewable carbon-free energy as a result of the demand to electrify all of our buildings. It is not possible to electrify a building that does not have adequate storage. BOMA's view is that electrification is a useful tool in the box. However, it is not always the answer. Only when we link renewables with storage can we get to the ultimate goal of highly efficient, carbon-free buildings which are environmentally friendly and, more importantly, economically viable. I would encourage you to visit the BOMA website and review the BOMA Electrification Study, which was published in 2023, showing the benefits of electrification, but also highlighting and illustrating those situations where electrification may not be the best possible solution. As we progress through 2025 and 2026, one of the things that BOMA International will be working on is an increased investment in research and development by the Department of Energy and their Energy Efficiency and Renewable Energy Office. This is the office that actually makes the investments in the technologies that we're going to need going forward. We appreciate this support as we advocate in front of the administration for increased research and development funding for these important programs.